Day 728 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. In a day, we have question number 396, rotate function. The difficulty level is medium, so don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums of length n. Assume Rk to be an array obtained by rotating nums by k positions clockwise. We define the rotation function f on nums as follows. F of k is equal to 0 times Rk of 0 plus 1 times Rk of 1 plus so on and so on to n minus 1 times Rk of n minus 1. Return the maximum value of f of 0, f of 1, all the way up to f of n minus 1. The test cases are generated so that the answer fits within a 32-bit integer. All right, y'all. So that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 4, 3, 2, 6. Our output is 26. So let's go ahead and take a look at this output, or this explanation, so we can see how they got this output from this input. Boom. So from this input right here, let me go ahead and copy and paste this over here. Boom. So the first thing we're doing is we are just doing multiplying each element by the index, right? So 0 times 4, we have 4 at index 0, 1 times 3, we have 3 at index 1, 2 times 2, we have 2 at index 2, and then 3 times 6, we have 6 at index 3, right? Boom. That's right here. Then we want to rotate it, right? Because we want to find the maximum value. So we're going to rotate it and see if we can get a larger value. Boom. So come right here. After we rotate it, we move this 6 to the front. Boom. So now the 6 is at index 0. Boom. Once the 6 is at index 0, we do the same thing. 0 times 6. Once again, now 4 is at index 1, so 1 times 4. 3 is at index 2, so 2 times 3. And 2 is at index 3, so 3 times 2. Boom. When we add those up together, we get 16. The first one, we got 25. Then we're going to rotate again. So now we're going to move this 2 to the front. So let me copy and paste this. Boom. Let's rotate it. We're going to move this. We're going to move this up here. Boom. And now, once again, we have 0 index 2, 6 at index 1, so on, so on. When we do this, we get 23. So let's just put this up here. This is 23. This is 16. And this is 25. Boom. But we're not done yet because now we're going to move this 3, right? We got to rotate the 3. We still have one more combination we could try. So let's bring this down here. Boom. Let's rotate this 3. So now 3 is at index 0. Boom. So now, once again, 0 times 3. 3 is at 0. 2 is at 1. 6 is at 2. And 4 is at 3. Index 3. When we add all those together after performing these operations, we get 26. So this would be 26. Boom. Then when we compare all of these, 26 is the maximum value, right? So that's how our output is 26, right? Because this 26 is greater than all of the other values that we were able to obtain. Boom. So our output is 26. Now, just in case that didn't make sense, let's take a look at example 2, where example 2, they might try to throw a little trick question our way, but it's not really a trick. It's just we only have one element in the array. So in example 2, we have our input nums equals 100. Everything times, so it would be 100 times 0. Everything times 0 is equal to 0. So our output would be 0, y'all. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we want to do is we want to get the number of elements in the array. So we're going to say let n equal nums.count. Boom. Then we're going to get the total sum of all elements in nums. This is reused to efficiently compute rotations. So we're going to say let sum equal nums.reduce, open up the parentheses, 0, comma, plus. Boom. Then we're going to compute the initial rotation function. So we'll come underneath this, declare a variable called f, set that equal to 0. Then we'll say for I in 0 dot dot less than n. We'll open up the brackets and we'll say f plus equals I times num square bracket I. Boom. Then we're going to initialize the result. So we'll come underneath this and we'll say declare a variable called result and set that equal to f. Boom. Then we're going to iterate through all rotations. So we're going to say for k in 1 dot dot less than n. Open up the brackets and we're going to use the recurrence relation. So we're going to rotate the array to the right by 1, and every element shifts 1 position forward, and this contributes to the plus sum. The last element moves to the front, and we're going to subtract n times that element. So we're going to say f plus equals sum minus n times num square bracket n minus k. Boom. Then we're going to keep track of the maximum value of f of k by coming underneath this, and we're going to say result equals max, open up the parentheses, result, comma, f. Boom. Then we're going to return the maximum rotation function value by coming underneath this, and we're going to say return results, y'all. Boom, that's all she wrote. Let's go ahead and give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 1 millisecond beats 50% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.